Hello, grade 8 learner. Welcome to your video lesson in mathematics, where we will be discussing how to identify angles formed by parallel lines cut by a transversal. This is based on the K-12 curriculum learning competency. The learner proves properties of parallel lines cut by a transversal. It's another great day to learn, so prepare your module, pen, and paper as you start watching and learning from this video lesson. Refer to your quarter 4 module entitled Parallelism and Perpendicularity for this module. For this example, we are going to classify the following pairs of angles. We begin by observing the figure. Locating the angles that are given in the problem will be helpful in classifying them. We have angle 1 and angle 8, angle 6 and angle 13. Since angle 13 is already identified, then we locate angle 9, and finally angle 2 and angle 16. Let us process what we know. In our figure, we are given that lines A and B and lines C and D are parallel to each other. When lines are parallel, this means that they do not have any points of intersection. Line A does not intersect with line B, and line C does not intersect line D. Aside from parallel lines, the figure also contains transversals, or lines which intersect two or more coplanar lines. Each line in our figure is a transversal. For example, line A is a transversal of lines C and D, so is line B. On the other hand, line C is a transversal of lines A and B, which is similar to line D. Now, if we take line C and D with their transversal line A, we create different types of angle pairs. Angles located between the parallel lines, such as angles 3, 4, 5, and 6, are called interior angles, while angles 1, 2, 7, and 8 are called exterior angles. The first type of angle pairs created by parallel lines cut by a transversal are corresponding angles. These are pairs of non-adjacent interior and exterior angles on the same side of the transversal. In this figure, the pairs of corresponding angles are angles 1 and 5, angles 2 and 6, angles 3 and 7, and angles 4 and 8. Another type of angle pairs created by parallel lines cut by a transversal is the alternate interior angle, which is a pair of non-adjacent interior angles on the opposite sides of a transversal. This means we focus on interior angles that are found on opposite sides of the transversal A. Thus, our alternate interior angles are angles 3 and 6 and angles 4 and 5. The next type of angle pairs is the alternate exterior angles, which is a pair of non-adjacent exterior angles on opposite sides of a transversal. In our figure, we focus on the exterior angles found on the opposite sides of the transversal A. Thus, our alternate exterior angles are angles 1 and 8 and angles 2 and 7. Another type of angle pairs is the same side interior angles, which is a pair of interior angles on the same side of a transversal. In our figure, we focus on the interior angles found on the same side of the transversal A. Thus, our same side interior angles are angles 3 and 5 and angles 4 and 6. Lastly, we have the same side exterior angles, or a pair of exterior angles that are found on the same side of a transversal. In our figure, we look at exterior angles on the same side of the transversal A. Thus, the same side exterior angles in our figure are angles 1 and 7 and angles 2 and 8. Let us solve. To classify angles 1 and 8, we have to locate the angles first. In the figure, we see that given lines C and D, line A acts as their transversal, thus showing that angles 1 and 8 are exterior angles. These angles are also located on opposite sides of the transversal A. This makes angles 1 and 8 alternate exterior angles. To classify angles 6 and 13, we check their locations. Angles 6 and 13 are angles created by parallel lines A and B cut by the transversal D. And according to their location, they are interior angles found on the same side of transversal D. This makes angles 6 and 13 same side interior angles. To classify angles 9 and 13, we look at their location. Angles 9 and 13 are angles formed by parallel lines C and D cut by the transversal B. According to their location, angle 9 is an exterior angle, while angle 13 is an interior angle. They are also non-adjacent. Since angles 9 and 13 are a pair of non-adjacent exterior and interior angles, this makes them corresponding angles. Lastly, we classify angles 2 and 16 by first locating them. We see that angles 2 and 16 are found on the same parallel lines C and D, but they are formed by different transversals. However, if we take angle 16 in the group of angles where angle 2 is, we find that it has the same position with angle 8. So if we transfer angle 16 to that side and locate it together with angle 2, we find that they are both exterior angles on the same side of the transversal A. This makes angles 2 and 16 same side exterior angles. Now that we have solved the problem, let us state our conclusions. Given that line A is parallel with line B and line C is parallel with line D, we now know that angles 1 and 8 are alternate exterior angles. Angle 6 and angle 13 are same side interior angles. Angles 9 and 13 are corresponding angles. And angles 2 and 16 are same side exterior angles. Congratulations for finishing this video lesson. Now apply what you've learned by answering the activities in the activity sheet. Happy learning! We'll see you again in our next video lesson.